Hello, and welcome to the first lecture for GIT335 Computer Systems Technology. My name is Nicholas Lindquist. I am your instructor, as you know. And today our subject is Chapter 1 in your textbook, Introduction to Information Technology, the Future Now. And I should say at the outset that as a student in this class, you are responsible for everything covered in the PowerPoints, in the textbook itself, and in the lecture. So you should expect and will find test questions from all three of those sources. Okay, so getting started here, the topics that will be covered in Chapter 1 are the mobile world, information technology, and your life. And Unit 1B is the basics of information technology. And in fact, the entire course will touch on both of these topics, not just this first chapter. So let's see here. The mobile world, information, and your life. As a result of developments in information technology, smartphones and tablet computers are changing nearly everything that we do. As I'm sure you're well aware by now, smartphones are changing every aspect of computing, in that the smartphone in your pocket is a computer in and of itself. In fact, I think that my mother is probably the only person in the world who has a smartphone and still only uses it as a telephone. But we now carry our computers with us everywhere we go. In fact, I have mine in my pocket right now on vibrate, and I'm sure yours is probably just as a guess, sitting less than 6 feet away from you at this very moment. It's interesting, the first Apple computer, the processor ran at 15 megahertz, which is 15 million clock cycles per second, which is ridiculously slow by today's standards, and that the first Apple iPhone, the processor was 550 megahertz. So as you can see, things are getting faster all the time. There's a concept in computing called Moore's Law, and I forget the gentleman's first name, but Moore is the one who made a prediction that every 4 years computers would become half the size, twice as fast, and hold twice as much data. And it's called Moore's Law because he correctly predicted that, and now it's a law, and that you should expect that in 4 years from now, computers will continue to get smaller and smaller and smaller. It'll become faster and faster and faster, and more and more and more data can be processed and stored. Anyway, moving on, information technology refers to any technology that helps produce, manipulate, store, communicate, and/or disseminate information. And in fact, we can define information as that which is processed by the computer, whereas data is what goes into the computer, and through you and the computer working together, information is produced. Here we are in 1.1, information technology and your life. So in this class, we'll talk about computer technology and communications technology. I think you can probably guess the difference between those two. Information technology can be used for a lot of different things, personalizing students' education. I think that's pretty obvious in that you're watching an online class. Unfortunately, it saddens me to tell you that you and I may never meet in person. And while that is in and of itself a little bit sad, at the same time, it is pretty cool that technology has advanced to the point where I could give a lecture on computers and you can watch it at home in your PJs or however else you're comfortable. What is misuse? Well, that is kind of a gray area. That's up to you. But in this class, the only misuse would be using technology to help you cheat on the exam, which I should also let you know that I know when you do that, because there is technology that allows me to know when you are misusing technology to get ahead in this course. Just fair warning. So here we are with more about online education. Online learning or distance learning is becoming more and more common. That's another big duh. So obviously this has actually been a push in education for quite a while. I remember 10 years ago, Dr. Crow, president of ASU, said that he wanted to see 10,000 points of light was the buzzword, in that he wanted 10,000 courses to be online. I think he wanted it in 10 years. And I don't think he actually met that goal. But as you probably know, it's good to set a ridiculously ambitious goal and not achieve it, rather than aim too low and hit it. So yes, online learning and distance learning is becoming more common, and I can give you a reason for that, because if you happen to be on the Tempe campus right now, you are well aware that there is only so much space that can be granted. They can't really build more buildings, they can't build more buildings, they can't really pack more students onto that campus, and so the only way for the university to continue to grow is to advance their online learning. Not to mention that you as a student probably very much appreciate the opportunity to not have to attend face-to-face classes. Also, we talk a little bit here about tutoring, simulation, and avatars. And as you may know, an avatar is a digital representation of yourself. And as you may also know, the term digital refers to anything that could be represented as zeros and ones. High-tech computing. So computers are playing important roles in telemedicine, robotics. If you haven't already had surgery performed by a robot, well, you should try it. It's pretty amazing. I've already done it twice this week. Money and business. Oh, no, this is an interesting topic. Such an interesting topic. Virtual means something that is created, simulated, or carried on by means of a computer or computer network. An easy way to think about this is maybe you've heard someone talk about a virtual computer or a virtual machine. That would be an instance in which, say, for example, you have a physical computer in front of you, and you have a separate installation of maybe, say, Windows 98, Windows XP, whatever, installed on your computer to where that other version of Windows is virtual in that it thinks it's installed on an actual computer and is the only operating system, but in fact it's not. One of my friends was actually just telling me that he runs a lab of about 200 or 300 servers that have 1,500 virtual machines installed on it. So hypothetically, he could do 1,500 times the processing with just 200 servers. Moving on, now this, like I said, virtual money is a topic that I find extremely interesting. You'll have to ask my wife. We recently were having a discussion about Bitcoin and the legitimacy of Bitcoin as an investment strategy. And for myself, I feel very strongly that it is, and I don't want to go too far down the rabbit hole with this stuff. But if you think about it, just maybe 10 years ago, we had CDs. Before that, we had records, we had cassette tapes. I still have those things. And now, what is our distribution method for music? Why, it's nothing at all. It's strictly zeros and ones. In the same way now, we have dollars, $5 bills, $10 bills, and those irritating coins. My boss doesn't even keep coins. He just throws the coins away or gives them back to the person who gave them to him. So we're reaching a point where the new money is no money at all. And there's many, many, many other reasons that I really like the whole Bitcoin model, and that's not really the right time to break into it right now. But virtual money is something that you should definitely keep your eye on, because I will give you my personal guarantee that in 10 years, you will be looking back on this moment and say, man, I should have paid more attention to that, if you're not already paying attention to that. Jobs and careers in computing. As I'm sure you are well aware by now, basic computer skills are required for most jobs. And it says here at the bottom, a good question for thought is, can you think of a single career that does not require any computer skills at all? The only one that I can think of would be like Fred Flintstone working at the quarry at this point. Even though I'm sure construction workers still have email to check. And I'm willing to bet that most of those construction workers use their smartphones to check their email. The world is changing so quickly, it's almost kind of scary to think about. But anyway, as it says here, basic computer skills such as Microsoft Word, spreadsheet software, etc., knowledge of file sizes, computer memory limitations, and networks are basic. I guarantee you that any 7th, 8th grade kid knows a considerable amount of these things already. Your personal life. Oh, such an interesting subject, isn't it? In that online relationship sites have become very, very in vogue for meeting people, in that they're almost certainly the best tool for the job in this day and age. If you want to meet someone, is it more likely to walk into a bar and happen to meet your 1 in a million special someone, or is it not much more likely to cast your nets into the digital sea and get to cull through a crop of possible mates much more quickly? So it's not a surprise that online relationship sites are becoming more and more popular, because they're simply better tools for the job. Information technology is pervasive. Duh. All I can say to that slide is duh. Okay, telephone grows up. Interestingly enough, 1973 was the first cell phone call. Maybe you remember, it's actually kind of amusing when we look back and see pictures of people like, hey, I'm in my car phone calling you, ha ha ha. And at the time it was very impressive, even though the car phone was like, you know, as big as your head and probably just as heavy. Today's smartphones can. Is there really any reason for me to read this slide? I have very little doubt that you are already well aware of what today's smartphones can do. Email. Email's mass impact. Ladies and gentlemen, I have a confession to make. I hate email. I hate email. I feel like it is a digital chain in which it's just frustrating. There's so many emails all the time that have to be replied to. It's so easy to just reach out and send an email to someone. And with the exception of my students, whom I very, very much enjoy receiving email from and communicating with them, In many other ways, email can be kind of a burden. However, it cannot be denied that it is a very effective tool for communication. I'm reminded of, what was the movie? Michael Crichton's Disclosure. I'm not sure if you remember that one, but that was one of the first films in which they demonstrated email. And it was so interesting at the time. It was like, wow, that's so cool that it was actually like a little box that appeared on screen, and it would unwrap and then the words would come out. And it was like, wow, that is so cool. But now if you think about it, I have a hard time imagining, like back in the 50s and 60s, how business was done in an office. Did people literally get up and talk to people with every little thought, notion that they had? Or did they send the secretaries? Or I don't know how that worked. I wasn't around. But email has definitely revolutionized the world. So another interesting factoid is I was reading an article online about 10 technologies that will be gone in the next 10 years. And I don't recall enough of that to describe those technologies to you, but at the end was a footnote that said the one technology that will not be going away in 10 years is email. It's here to stay, ladies and gentlemen. So here's a subject that a lot of people get these terms confused, and we're going to discuss how they are different for your own edification. Cyberspace is a term coined by William Gibson in his book Neuromancer. If you haven't read that book, I'd recommend picking it up. It's quite a there's a word for it, but I'd hesitate to say it in this recording. It's quite a mind jolt. And this book was written in 1984 to describe a futuristic computer network where people are plugged into directly with their brains. Now, there's actually another very interesting term. Maybe you've heard of people talk about the singularity, which is something that should be coming by 2025, as people are predicting now. I actually read an article by the head engineer at Intel, who's saying that by 2025, anyone who lives to that point will essentially live forever. Because at that point, all of the things that make us human, that make us different from each other, will be represented by zeros and ones, and will become software programs, and will be uploaded into a virtual world, and then we'll live forever as part of software programs. If you think about it, each of our DNA could very easily, and in fact it is, represented by zeros and ones. And each of our thoughts that pulses through our brains are tiny little positive and negative magnetic charges. So hypothetically, it should be possible to represent us as zeros and ones and to connect our brains to networks. And so perhaps William Gibson, as so many other sci-fi writers, was actually seeing the future. Anyway, I'd be surprised if that was not coming at some point in our lifetimes even. So anyway, the term cyberspace And so the term cyberspace is a term that represents that kind of imaginary world that is created by the presence of the internet. And the internet is that physical structure, as it says in the next line. The internet itself is a physical structure of phone lines, Ethernet cables, and internet backbones. As you may be aware, there are 7 major internet backbones throughout the world, and they go underneath the sea and across from one nation to the other, and they carry all the world's internet traffic. So when we talk about the internet, it is a physical thing that you could hypothetically touch. It's interesting. So all of the internet traffic that comes from Asia and those other countries over there enters the USA through one single network cable, and I believe it's in San Diego, or maybe it's San Francisco, where it comes up out of the ocean. And so all of the traffic between us and those Asian countries is exchanged through one cable. And so when you hear about entire countries being taken off the network, being taken off the grid, well, that hypothetically would be possible. And who knows, maybe that's something that may come to pass in our time. It's just a matter of just shutting down those physical cables. So the internet is physical. Cyberspace is kind of an imaginary, fanciful place that we all kind of escape to when you're doing Facebook or whatnot. And then the World Wide Web is something similar in that it's rather the technical formatting or structure that is required to carry those instructions across the network. And so while the internet is physical, the World Wide Web refers to the special formatting and technology that allows the transfer of digital information all over the world. Perhaps you're familiar with HTTP in that it's the beginning of every URL, Universal Resource Locator, that you type into your URL bar. HTTP stands for Hypertext Transfer Protocol, and that is the technology that allows the World Wide Web to work. in the transferring of documents. However, it's a little bit different in connecting the computers. The technology that allows that to work is actually called TCP/IP, Transmission Control Protocol, Internet Protocol. And so those are the two different technologies that allow the internet to actually work. Moving on, and now we arrive at Unit 1B, the basics of information technology. The 5 different computer sizes, as you can see on this slide, are supercomputers, mainframes, workstations, microcomputers, and microcontrollers. Supercomputers are something you may or may not be familiar with. Most of these are at places like MIT or NASA or something like that. And they are computers that are made of hundreds and hundreds and hundreds of processors that have special software that allows them to all work together as one common mind to crunch huge problems. Mainframes are very, very large, powerful computers that you might find in government agencies, corporations that power many, many, many tasks all at the same time. A workstation would be your desktop computer or your laptop. A microcomputer may very well be your Palm Pilot. No one uses Palm Pilots, I'm sorry. An iPhone or an iPad. And then a microcontroller would be something that would power perhaps your microwave at home or some other piece of embedded software. So here we are, supercomputers, mainframes, workstations, microcomputers. And then, so here we talk about servers, and the server is a specific type of computer. In fact, the two of them are very similar, except that a server has special instructions on it that allow it to send and receive requests for information through TCP/IP, Transmission Control Protocol, Internet Protocol. So servers basically are the physical hardware that makes the network work, in that they respond to requests for information, they receive when you type in, I want to go to Facebook, it sends a request to a Facebook server, and that particular page that you have requested is sent back to you from that server, and then it's interpreted. The HTML and the other files are interpreted on your own workstation computer through the browser, and that code becomes the page that you interact with. Understanding your computer. That is basically the point. There's so many points to this class, really. But one of the primary objectives is for you to understand your computer, the purpose of your computer, and how it is made up with software and hardware. So interesting, isn't it? When you think of how a computer works, there are 2 different basic parts to your computer. There's the hardware and the software. And an easy way to remember this is if you can touch it, it's hardware. If you cannot touch it, then it is software. It's kind of interesting. I can't help but think to the parallels of the human body, and that everything you can touch would be your hardware, but then there's that one critical part of us that they can't seem to pin down, and that would be our software. Whatever that may be, who knows? And here we have the basic operations of a computer. All computers use 4 basic operations in communications. Input is that data that goes into the computer to be processed. Processing is the actual processing that transitions or transfers or transforms that data into information, meaningful information. Storage is the data that is waiting to be processed. And output is what comes out of that processing procedure. That could be information onto the monitor, that could be to a printer, something like that, and the results of processing. Maybe your completed document, your completed Photoshop file, whatever it may be. And then the communications are the parts that actually facilitate the sending and receiving some of that data. Those are the basic operations of a computer, and here they are in visual form. Customizing your desktop computer. What would you need? Well, there's input hardware that is required. This is assuming that you have a desktop computer, which so many people still do, and we won't debate whether or not those will become obsolete soon enough, but I'm sure we'll do that in a future lecture. For the time being, for the purposes of this slide, we will assume that you have a desktop computer, and for that you will need a keyboard and a mouse, and those are input devices, and that they accept your input. Inside the system cabinet, you have the processing and memory, the guts, the nitty-gritty of the computer itself. The CPU, the central processing unit of the computer, which is basically the processor. The memory chips, random access memory, that is called the volatile storage, and that when your computer loses power or you shut it down, the absence of power causes that data in the RAM to wipe itself out. Whereas the non-volatile data is stored on the hardware or on the hard drive. And then the motherboard is sort of like the map. If your computer was a town populated by different villages or by different buildings and whatnot, the motherboard would be the map that holds all those things together and allows them to talk to each other. Oh, here we are, great. Here's an image of, as you can see right here in the middle, here is the motherboard. Here we have the expansion slots for things to interface with. Looks like you can get some RAM there down at the bottom. These white strips that you see on the left would be for adding video cards. Over here it says plug microprocessor into motherboard, fan to cool it all down. And then here's the inside of what a desktop computer looks like. On this slide we discuss the different sizes of digital data, different storage sizes, the amount of data that can be stored. This slide is not technically correct in that 1 byte is actually 8 characters. It can be a string of zeros and ones up to 8 characters. 1 bit is technically 1 character of data. It can be either a 0 or a 1. A kilobyte is just over 1,000 bytes. It is 1,024 characters. A megabyte, mega, the M, can be thought of as a million, which is just over 1 million characters. A gigabyte is just over 1 billion characters, and now we are into the terabyte age, in that over 1 trillion characters is now, we have terabyte hard drives, 1 to 4 terabyte hard drives. Like I said earlier, I really like old computers, and I get a kick out of things like 256 kilobyte RAM chips, which is absolute nothing nowadays. We have even 256 megabyte RAM chips are useless. We don't use those at all anymore. So in our lifetimes, we will be seeing petabyte hard drives. I have no doubt of that, if hard drives even continue to be relevant, because perhaps it won't be long before our computers retrieve all their information via the network. Your computer is just a dumb terminal that boots up and then receives all of its instructions via the network. It won't even be necessary to install an operating system onto your hard drive. Anyway, I believe following the petabyte is an exabyte, and it is possible we will get to the point in our lives where that will be a meaningful term as well. On the next slide, we talk about output hardware, which the output is that information coming out of your computer. Getting video out of your computer, I'm not exactly sure why there's a digital camera there on that slide. For the most part, I would think of that more as an input device, inputting those videos that you've recorded into your computer. Sound cards, however, there's no debate about that, whereas a sound card takes digital sound files and plays them for your ears' listening enjoyment. Speakers are the same way. A monitor takes video information and displays it on your monitor, 1 line of pixels at a time. And then a printer, technically still relevant, I suppose, in that people do print things, but how much longer will we even be doing that? That qualifies as output hardware, however. So moving on to communications hardware. Perhaps you remember one of those ancient modems that we used to have to use to dial up to connect to the internet. We do still have modems, in that the term modem means demodulator, for taking analog information and making it digital. So the device in your computer that connects to the internet, the Ethernet port or whatever it may be, is still technically called a modem. And then here once again is your basic PC system. The PC itself, the input hardware and the output hardware, living together, happily playing together to accomplish whatever it is you ask them to do. Moving on, software, as I said, is anything that cannot be touched. There are 2 different types of software. There's system software and application software, and we will be talking about both in this class. System software could technically be defined as the operating system, which tells your computer each time it wakes up what it is and how it should operate. It tells the computer what the different parts inside of it are and how it should use them. It tells your computer how to interact with the different applications and your commands. And some examples are Windows, Unix, Linux, and the Mac OS. The different types of operating system are, there's graphic user interface, and then there's command line interface. So for instance, Mac OS X would be a graphic user interface in that it accepts your commands, and then unbeknownst to you, it transforms them into text-based commands that Unix underneath it We'll get more into that, I'm sorry. I don't mean to be too long in this first lecture. Application software would be Microsoft Word, Microsoft Outlook, Adobe Photoshop, those sort of specified software applications to accomplish work on your computer. Where is information technology headed? Well, we could talk about this for days and days and days. But as we said earlier, Moore's Law, computers are getting smaller and smaller, they're getting faster and faster, and they're becoming more and more affordable. We are becoming more and more connected. Duh. Interactivity, and that as this guy is doing, you can interact with computers in your car. I was reading an article recently that says that there's millions and millions and millions of lines of software code in every computer or every car that is manufactured today. And honestly, that makes me a little uncomfortable because we all know how bug-filled code can be. And perhaps I've actually seen pictures of cars that have been hacked, and on the speedometer it displays weird random information, and you know that actually your car's software has picked up a virus, which is just a little bit creepy for me. Convergence, as we said in the introductory lecture, convergence is the combining of different industries into one. So your phone, now you can watch movies on your phone, you can make phone calls on your phone, you can access the web on your phone. Cloud computing, this is kind of a polarizing concept in computing in that is it a good idea or not a good idea? In some cases it's an excellent idea, in others it is not so much. If you are aware, recently some celebrities who were storing things in the cloud had all of their information stolen because it's outside of their hands. Whereas having just stored on your own computer, do we really want to always accept Google, Apple's claims that they can keep our data safe for us, or Facebook's claim that they will always be able to keep our data for us? When you upload data to the internet, it's gone. It's completely out of your control forever. When you upload a picture to Facebook, just because it's private doesn't mean it's not saved to 5,000 to 10,000 different computers all over the world, and you will never be able to retain exclusive ownership of that particular picture, whatever it may be, ever again. So cloud computing in a lot of ways is good, and in other ways, well, maybe we should be thinking about it before we do that. Artificial intelligence, no doubt you're familiar with that concept. Ethics, hopefully you're familiar with that concept. And I'm pleased to say we have finally completed the first lecture in this class, the Introduction to Information Technology. Please, my dear students, stay tuned for Lecture 2, which will be equally as thrilling. Thank you for bearing with me today. I will see you online again shortly.